Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking back at 1.9. I know we covered part of it already, looking at holes and x-intercepts and graphing from these rational functions. But today we're going to start looking at solving. When you solve rational functions, one thing to note is a solution is just an x-intercept. So if you were asked to solve if it's just equal to 0, all you need to find the values that make it 0. Those are just x-intercepts. Today, though, we want to solve an inequality. So one thing you need to notice is the sign that you're given. In this case, we have a greater than or equal to sign. Okay, so we are trying to find all of the values of x, right? It's a range. You're going to have multiple values that are greater than 0. In other words, we want to find all of these spots where our graph would be positive. Okay, let me try and fix those letters. All right, well, looking at this function, there's two things that will kind of change your value from being positive or negative. One of those is if it goes through the x-axis. So one thing we need to identify are the x-intercepts of the function. The other thing that could change whether your graph is positive or negative is a vertical asymptote. Okay, because remember, one of your sides of your graph might be shooting down, the other might be shooting up. So wherever it might change like that, that can always occur at a vertical asymptote. So two things we need to identify from our function. The x-intercepts of our function, if you were to either factor the top and solve or just set the top equal to 0 and solve, you would end up getting x equals positive 2. Add the 4 over and divide. Your vertical asymptote, we have an x equals positive 9. It is raised to the 4th. That doesn't necessarily mean too much to us. But you do have an a vertical asymptote at x equals 9. Well, knowing that stuff, what we can do is we can start to graph our solution. Since we're going to have more than one value, we're just going to graph it on a number line. So I've got a value of 2. I've got a value of 9. It doesn't need to be perfect. You just need to understand the idea. Above 2, this value was an x-intercept. Because it's an x-intercept, right, you could either have a hole at the x-intercept or you could have an actual value there. So we need to figure out what do we actually have. The way you figure out what you have is by looking at the inequality sign. In this inequality, we have the equal to part. That's telling me that I'm allowed to be equal to 0. So what that means is I'm going to fill in my circle. Okay. The second one, we want to know, do we have an open or closed circle as well? Well, at a value of 9, it's a vertical asymptote. Because it's a vertical asymptote, you're never actually going to have the value of 9 make it so this function's equal to 0. Vertical asymptotes, you don't actually have a value there. So we actually have to have an open circle there. Okay. Any discontinuity, you would have an open circle. So vertical asymptotes or holes would both be open circles. The only time you have a closed circle above the 2 is you have the equal to part for an x-intercept. Okay, so a few things to look at. Once we have that, the next thing we're going to do is start to figure out where is our function greater than 0? Where is it positive? Well, in order to do that, all we care about is whether it's positive or negative, right? I don't care about the actual numbers. I just want to know, is it positive in these different sections? In each of these sections, it's not going to change positive to negative because we said the only spots it changes are x-intercepts and vertical asymptotes. So you can choose any value to the left, to the right, or in the middle of these to determine positive, negative, or 0. Let's look first to the left of 2. To the left of 2, I don't care what value you choose. Maybe I choose the value of 0. I want to know if I plug that in, does that give me a positive or a negative value? Well, 2 times 0, that would go away, so you have a negative 4 on top. I don't care about the number, just the sign. 0 minus 9, well, that'd be negative, but if I take a negative to an even exponent like 4, it's going to come out positive. So this entire fraction has to be negative. Because we are looking for the values greater than 0, this fails our test. Let's look at the next one. Choose a number between 2 and 9 now. Maybe I choose the value of 5. Let's plug that in and see what we get. 2 times 5 is 10. 10 minus 4 would be a positive number. 5 minus 9 again is negative, but since it's raised to the 4th, that comes out as a positive. So I believe this entire thing is positive. Between 2 and 9 is positive. That's what we wanted. We wanted the values greater than 0. Between 2 and 9, that would satisfy this equation. You can shade in between those two spots. Next thing, check a value to the right of 9. Maybe you choose a value of 10 to see what that gives you. 2 times 10 is 20, minus 4, that would still be positive. On the bottom, 10 minus 9 is 1. To the 4th is still positive, so that entire thing to the right of 9 is positive. That means it's going to go to the right forever and be above. So what we did is this graph diagrams where our graph is positive. From 2 to the right, it is positive. So we need to create some sort of inequality, or not inequality, some sort of interval notation for this. Because 2 has a filled-in circle, we're going to have a bracket. That went all the way to the 9, but there was a vertical asymptote, so I know that I need a parenthesis. Always put your union symbol in between. That just means or. It's just a math symbol. Just put it in between. Same idea as like a comma. In this scenario, at least, we're listing all of the values it's above. So from 9 then all the way to the right, it was above 0. It was greater than 0, so we'd have our answer there. This is your solution. These are all of the values that x could be. X can be between 2 and 9 to give you a positive number in this function. X could be 9 or greater to give you a positive value in the function. Let's look at one more example. So find your x-intercepts and your vertical asymptotes. If there's any holes, that is important as well. So if I took the top and set that equal to 0, you're just going to divide and take a root. So that's just x equals 0. Your vertical asymptote, if you were to solve both the things on the bottom, I believe you would get positive 4 as well as positive 8 is what it's looking like to me. Okay, make sure you solve both those to double check. Now create your graph. Plot each of those points that matter. So I care about 0, I care about 4, I care about 8. Make sure you have a circle above each of those values. Above 0, that's an x-intercept. X-intercepts can be filled in, but they don't have to be. Check the inequality sign to know. In this case, it's strictly less than 0. Because there is no line underneath, because I'm not allowed to equal the 0, I use an open circle. Above 4 and above 8, those are both asymptotes. Those are discontinuities of your function. Those need to be open circles as well. Vertical asymptotes are always open circles. X-intercepts can be different. We now need to know, okay, where is our function positive versus negative? And what we want in this case is to be less than 0. That means I need to be negative. Let's find the values in which our function is negative. So looking at this, use different intervals to check. We need to be in between each of these and to the left and to the right of the outside ones. So I need to be left of 0. Let's say negative 1. Let's go back to the original function. Okay, so if I plug in negative 1, we need to figure out what happens. If I were to plug in negative 1, it would look something like this. Realize the minus and negatives on the bottom, you can just change those to positives. You don't really need the second set of parentheses. We're at the spot where we can make that logical step in math. So, okay, the top, that would be negative 5 times negative 1 to the 4th. Negative 1 to the 4th would be positive. The 5 is negative, though. On the bottom, 1 and 4 is positive, 1 and 8 is positive, and if you square it, it is still positive. This entire thing would be negative. To the left of 0 is negative. Checking between 0 and 4, just choose a number that is nice, maybe positive 1 in this case. Remember, we made each of the values change signs when we plugged in, so now we're going to have negative 1 on the bottom when we plug in. The top would still be a negative times a positive. The bottom would be a positive times a positive. So that entire thing still looks like it is negative between 0 and 4. That is, again, what we wanted, so we can have our line in between those two spots. We did want less than 0. We wanted negative values. Check that between 4 and 8. Maybe choose a value of 5. Again, it doesn't matter what you choose as long as it's in between. That'd be negative 5 plus 4, negative 5 plus 8 squared. That top would be a negative times a positive. The bottom looks like a negative and a positive. So this entire thing would be positive. Do not fill that in on our number line. And lastly, to the right of 8, maybe you choose a value of 10 and see what happens. So negative 10 plus 4, negative 10 plus 8. Again, the reason these ones are changing is it was negative x in both of those spots. So the 10, the 5, the 1s, they did change signs when you plugged them into the bottom. Okay, just a reminder there so we're on the same page. Getting our values, then let's see what that comes out to. That would be a negative times a positive on top. That would be a negative times a positive on bottom. Okay, I do know that negative 10 plus 8 is negative 2, but if you square that, it does come out as positive. So this entire thing then is positive after that spot. So we know our function then is negative. It is less than 0 just on that left side of 4. So we create our interval. We said to the left of 4, that means it went all the way to infinity. We had to stop at 0. Okay. Notice it's an open circle, so it's a parenthesis instead of a bracket. Union, so that's part of our solution. Union just means or. So or our solution can be between 0 and 4, both with parentheses because the holes are open. Okay, those values help you separate your different intervals. Each interval does need a union symbol in between it, and then you can get your final answer, which is this. This tells us x can be less than 0, or x can be between 0 and 4. X is not allowed to be 0 itself. It's not allowed to be 4 itself. It's not allowed to be 8 because those are all open circles. If they were closed circles, then those values itself would work. If you have questions, if you need something, please let me know. Again, this was 1.9, solving rational inequalities.